If we want to understand the behavior of a simulation in which we want to inject errors, then we also need to understand the behavior and performance of the error detection and error correction mechanisms that we are using in there. In this module, we shall first look at how errors can be injected into the simulations, such as bit error rate and packet error rate. And correspondingly, if we want to understand the behavior and the limitations of parity scheme, which is the simplest of all, we would have to modify the error injection model, which is incorporated by default in Omnet++. For that, let's first look at how the errors are induced by the channel. In INET, if you recall, the simple modules and the compound modules are connected through channels. These channels, also known as the links, have certain parameters. Two of the parameters which are related to error are the bit error rate and the packet error rate. These are assigned in the values, for instance, 10 to the power minus 4, 10 to the power minus 5, and minus 6. And when these values are assigned, then the channel is going to run a pseudo-random number generator. And if the random number generator generates error for the transmission of packet, then all the channel has to do is the channel incurs a change in the flag, which it calls the error flag in the packet object. This packet object, which would be processed as a packet by the receiver side, now contains an error. Regardless of where exactly the error has been made, the packet now contains an error. This is how we incorporate the bit error rate and the packet error rate into our communication channel. When the receiver receives such a packet, it looks for the presence of the flag in the packet object. Of course, since we are only interested in seeing the behavior of error detection scheme, not exactly error correction scheme, which goes on to determine which bit is in error and it flips the bit to correct the error. Here we are only concerned with error detection. So when the receiver realizes that the packet object now contains a flag bit, it discards the packet, considering it to be corrupt. That is why we see that the sender and receiver have established a kind of communication link which is error prone. In INET, let's say we have the basic NED file with data rate channel as the object. It has various parameters, and as it has been said that the bit error rate can be assigned a hard-coded value, that is, say, 10 to the power minus 10, which is, of course, for very noisy environment. Using this mechanism, the error is hard-coded, but if we are interested in knowing how parity scheme works, that is, even parity or odd parity, we have to look at the pattern which is going to determine the failure of the parity scheme. That is, if the errors are injected into the channel such that two simultaneous bits are flipped, the parity scheme is not going to work. And if we want to see the parity scheme failing, we have to define the data pattern so that the corresponding error model can be visualized. You can achieve that by inducing errors in the parity encoded data which goes undetected.